Receiving students and teachers. You may be seated. Okay, we're still on the same strand, same sub-strand, outcome, and unit title. Now, in a previous lesson, we viewed a video on submarine. Now, question, you are to tell me how can a submarine sink and float? Receiving students, please, you give your answers to your teachers, and we have the class to give me their answer. Let's have Malcolm. Malcolm, are you ready with your answer? Anybody else? Livingstone? Can you help Malcolm with answer to that question? That's a revision question of the previous lesson.
When air pressure is applied, the submarine floats.
When air pressure is applied, the submarine floats. Good try, thank you. Anybody else besides Livingstone? Michelle, thank you.
A submarine sinks when its density is increased, like when the tanks inside it are filled with water. It puts on more pressure or weight to it, and so it sinks down. And when the liquid or water is released out from the tanks, gas is then put in, and so the density gets less, and so it floats.
Very good, thank you. A good answer to that question. Now let's see our next question. This is still on the previous lesson. Why did the object, this is the object that you made out of straw and paper clip, why did it sink when pressure was applied and float when pressure was released? Receiving students, that's another question for you. Try to give the answer to your teachers, and we'll have the class also to come up with their answer. Let's have someone from the class. Eddie?
When the pressure is applied, the air is removed, and you pump the object pump the water in. That makes it weight.
Okay, good try, thank you. So we know that when pressure is applied, we find that the object sinks. Now this is because air is released from that object, and water takes the place of wet air, and the object becomes heavier. It's more dense than the water, so density of the water, so it sinks. And it's opposite to that. Once it's released, it's lighter than water, so it floats. Now you were also given homework, the receiving students as well as the class, on why did the unpeeled orange float and the peeled one sink. There were two pictures. One is of the boat and the other is that orange. We see that the one with the skin is floating, and the one that has the skin that has been removed, it sank. Why? That's an homework for you. You should have had enough time to look through that, discuss, and come up with your answers. Okay, anyone from the class to give us the first answer to the first question? You others should be also preparing for the second one. This is homework, not a new work given to you now. Thank you. Dinah.
This is because when the skin of the orange were peeled, the air released, so it has more density and the one that unpeeled one.
Okay, good try, Diane. Now we see that when you peel an orange, you find that the orange skin is not very heavy. It's very, very light. So the actual orange is covered by the skin that is very light. That is why, because it's very, very light, the density is less than the density of water, so it floats. Once the skin is removed and the actual orange is left, it becomes heavier. And the density is more than water, so it sinks. How about the boat? Boat, we know that it's made of metal. And we know metals are very heavy. How comes we have boats, very big ships, especially those students from the coastal areas? You all have seen big ships. Maybe you have wondered how comes that big ship that is made of metal is able to float on the sea, the surface of the sea. Let's have Natasha to give us her answer.
Because the density of the salt water is bigger than the boat or ship.
Okay, good try, Natasha. Now, if you do not know, students, we know that a ship is made of metals, but in the ships, those from the coastal areas, if you have traveled by boats or ships, ships have a lot of rooms. They have a lot of rooms and hallways, and all these rooms are occupied by air. Air takes up all the rooms that are in the ship. So when the air makes the ship that is made of metal lighter, so the weight of or the density of the ship becomes less than the density of the sea water or salt or sea, so it is able to float. Now, our lesson topic, it says solids, hotter or cooler. Now, you have been asked to come with some materials. I hope you have come with those materials, receiving teachers. If you are unable to get all those materials that you were required of, then probably you could just observe what the model class is going to do, and later you can go through with your classes. I'd like us to check that when you get your trays of materials, the model class, I'd like you to check to see that you have all those materials with you. Now, in that list of materials, we have aluminum rod. Now, because we don't have that available, we'll be only working with copper, glass, and iron. So please, the class, model class, once you get your materials, I'd like you to check on to see that you have all those things. And if I can have one person from each group, the runners, to come up and pick your materials. Please are careful with it that you don't spill the spirit in the banners. Now, before we go to our experiment, I'd like us to have a look at our safety rules, what we must take care of. There are some apparatus or equipment that you are going to use which are harmful. They can harm you, so we have to look at our safety rules before we can go on. Now, the first one, you have to be careful with heat, as you are going to be working with heat, and especially wax. Wax, and also if you have brought your own lighters, I'd advise you not to use your own lighters. We will come around and light the banners for you. Now, second, it says stand away from the banner when carrying out the experiment, please. Class, I'd like you to take your worksheet handbooks out quickly. Receiving students, if you do not have the books, I have the instructions on the screen, so you can take note of it together with your teacher. Now our first instruction is on, and I'd like the class together in your groups, you discuss quickly and come up with your answer. You're all to do that now before we go to the next instruction. I do not wish to read what is there. I'd like you to read it for yourself and do what it says. We worked on that yesterday. Okay. Please, while you are doing discussing on that, take note you are not to use, you were told to bring lighters, however, I've told you not to use it. I will come around and have your banners lighted. Our discussion for our first instruction should be over now. Your second instruction. You're not working on the table yet. Right, let's see what you have for your prediction before we can actually go on doing the experiment. You have to predict which substance will have its wax melt fast and which one won't. Now, in your worksheet handbooks, and I also had it done on the big paper. You're going to make your predictions there. Okay? So, where it says, my prediction wax melt fast. Now, you look at this. We are working with this tree here, not this. I've already told you that because we don't have that available. So, looking at glass, copper, and iron, you have to make your predictions. Which one you think will the wax melt fast, the glass, copper, or iron, and which one will be slow? So you should come up with that. You also have it in your worksheets to do that. So let's see. The first one, which one do you think will have its wax melt fast?
Iron.
Iron. So this one says, okay, which one will not have the wax melt fast? Will be very slow. Michelle? Can you have the what to give your answer?
Glass.
Glass, okay. We have those two, Estelle and her friends, they predicted that iron will have its wax melt fast, and Michelle and her friends, they said glass, the wax will melt very slow or slowly. We'll see that. Now that's the table. We have it, teachers, you have it on the big chart and also on the screen. Now before we go to the instructions, I'd like us to go through especially the third column where it says timing. Timing. Please, if I can have everybody looking this way. In timing, the third column, it says we have heating and melting, all of them. They all have heating and melting. We also have total time. Now, when you start heating, you are going to time yourself. You look at the clock to see what time you start heating that substance, whether it's copper, glass, or iron. You record that time. Melting, once you see the wax start melting, you write that time. And you are going to find a difference between those two figures to get the total time that it took for the wax to melt. Okay. Now you are to light your banners. If I can have the class, please, and the receiving students. I'll use the glass rod as an example to show you where you should hold the substance for heating. Now, you should have one end coated with wax and the other end free, nothing on. What you do, you have your tongs there. You're going to hold onto the end of the coated part of the substance that you have. Okay, and you are going to, the one that is not coated, you put it over the flame. Okay, you put the one that is not coated over the flame. And you hold the substance at the end of the part that is coated with wax.
So second is going to be it will take long time.
We are starting with the glass rod. You have to also observe and record the starting time of heating the substance and melting of the wax. I've already done the explanation of that earlier. You are okay with the one? 1 minute. Not very close yet. If you find one of the substance takes a lot longer time, then you can stop and go on to the next substance. If you find that the substance is taking too long, you finish with the rod, the glass rod. Yeah, don't worry. It's okay. We are doing an experiment. It broke, so you have to stop. Okay, it broke, so you stop. Yeah, that's your findings, so you have to take note of it. I've already told you, if you find that it takes a long time for a certain substance, please you move on to the next. Now you should finish with glass and go on to the next one now. Copper. Can you see the heat coming, the what? But you will have to time it melting. It's starting to melt now, so have your time. You can kiss him, I'm melt now. Why are you kissing things? What happened?
No, I tried to give this, you know.
That's what I told you. Did you? That's why we have that say. Everyone should be on the last substance, iron. The others should start working out the difference. The other group members, you should be working out the difference to come up with the total time for each of those substances. After you have found the total time for each of those substances, make sure you fill in where it says good conductor and poor conductor. There are three substances, so which one is a good conductor and which one is not? You just give a tick under each of those columns. It's already melting, so finish now. Stop now. If you have finished your experiment, I'd like you to answer the question that you have in the worksheet. For the receiving students and the teachers, if you don't have the worksheet, I have the question on the screen. long? All finished. What's your time there? The total time? Did you come up with your total time? So if you have, your starting time was 10 past, or 8 past 10, and it started melting 12 past 10. So you are only taking away the, what? The hour or the minutes? The minutes, okay? So how long did it take? If you take 8 away from 12. Huh? Oh, copper. Okay, and how about a glass rod? 10, 12. Okay, then you started there 8 past 10, huh? And when did you remove the rod from the heat, from the flame? The time you remove the rod from the flame, you should have it recorded, and then you subtract that to see the time. And then you try to tell the difference. Eh? I hope you have all found a difference between the heating time and the melting time of the wax. Difference meaning you are subtracting the two times. The time that you started heating the substance and the time that you saw the wax started melting. So you are actually subtracting those, especially the minutes, to get your total time for each of those substances. Taking too long. Right, class and receiving students, we are going to go through our findings. We have it recorded on the results table. Now I'd like that group to get ready. With your timing for glass, copper, and iron. If I can have you to record them on the big chart that we have, please. Now we will have Diane to record quickly what they have, the results that they have, and she'll tell us of their findings. You've seen that results table. Diane, you will have to fill the other columns too, where it says predictions. Oh, sorry, we've already done that. The good conductor and poor conductor columns. Now, if you can tell us something or your findings, because we have different total time there. With glass, we have 3 minutes, copper, half a minute, and iron, 2 minutes. If you can tell us something about that, Diane.
The glass rod is not a good conductor to conduct it because it took 3 minutes, but it did not melt. And the copper rod is a good conductor because it conducts the heat faster than the other rod. It took half a minute, it's like 30 seconds to melt. And the iron rod, it took 2 minutes, but it can conduct it slowly than the copper rod because the copper rod melts faster than the iron rod.
Very good, thank you, Diane. Now, if I can have Fiona to give us the answer to that question we have on the screen, what herself and her friends came up with. How do you know which substance is a conductor and which is an insulator? You've just done the experiment. How do you know? Anybody else who would like to have Fiona from the class? Michelle?
By seeing how long or fast it takes for the wax on each rod to melt. Because in a conductor, and if the wax melts quickly or fast, we can say that it is a good conductor of heat because it is a conductor. And an insulator doesn't allow heat to pass through, so if a rod doesn't melt quickly, then it is known as an insulator.
Very good, thank you. Michelle, a good answer. Okay. Now, you also have teachers, if you have the worksheet handbooks, if your students have them, there is a passage there for the students to do. I'd like the students to do that as their homework. The class will also do the same. You read and you do the passage for homework. Now, we have just seen through that experiment, Michelle has given us a very good explanation of a good conductor and a poor conductor. Poor conductors are known as insulators. She has given us a very good explanation, and that should help us to know and to understand what good conductors are and poor conductors are. Poor conductors are known as insulators. Metals are conductors of heat. But as we have seen, there are some which are very, very good conductors and some which are good conductors. Insulators are poor conductors of heat. Have that copied quickly. different substances conduct heat at different rates, and that's what we have just seen in the experiment that we have done. The movement of heat through solids is called conduction. Now, those substances that we have used, example, a glass, there is no movement of heat through the glass. That's why the wax on the glass did not even melt at all. But we have seen in copper and iron that heat actually moved through the substance from one end to the other end. That's why the wax was able to melt. If I can have someone to give us a key phrase. Thank you, Rachel.
Conductors.
Conductors. Okay, let's see what I have. Heat conductivity is our key phrase for this lesson. Our next lesson is on solids. How do I know? This time it's electrical conductivity. Now we have a lot of materials to help our teachers to collect students in the receiving schools as well as the class. Class and the receiving students, I'd like you to also take note of all those materials that you are going to help me and your teachers to collect for the next lesson. And with that, thank you all for your participation. Thank you all.